Phenomena. Phenomena. Phenomena.
Hey, welcome back. Algebra 2. We're on to chapter 6.4, Rational Exponents. Grab your pencil. Let's go. Rational exponents. We need to use your calculator to compute the following. Hey, note, some of you that have a certain calculator, we're going to need to make sure we use parentheses around our exponents. So, if you check out my handy dandy calculator, I'm going to type in 9, the little caret on the far right over here. For most of you, if you have just a regular TI-83 or a scientific calculator, we're going to go parentheses 1/2. So 1 divided by 2 into parentheses. If you hit enter, we get 3. If I do 16, so 16 raised to this calculator is a little different. Takes it to the 1/2, we get 4. If we do one more, we go 49 raised to the 1/2. Your calculator gives you 7. If we take 8, skip to D, we go 8 to the 1/3. Okay, we get 2. If we do 64, caret 1 divided by 3, you get 4. And if you do 125 raised to the 1/3, we get 5. So what does 1/2 exponent do? Well, if you notice, relationship between 9 and 3, 16 and 4, 49 and 7, they are roots. So if we take the square root of 49, we get the answer, 7. Okay, if you look at D, E, and F, we have 8 and 2, 64 and 4, 125 and 5. You'll notice you're taking cubes. Okay, so what do you think will happen with 125 to the 2/3? Yes, you're hopefully right. Cube root, and we have squares, so square on top, cube root. So the key concept we need to know, if the nth root of a is a real number, m is an integer, and m divided by n is the lowest terms, in other words, reduced. Okay, we can take, if a to the 1/nth, notice we're just taking the nth root of a, or a to the first. If it's mn, in other words, if we have 2/3, 3/4, 4/5, and so forth, we're going to write, there's two ways. Okay, the top number, m, is the exponent, so like this, or in here. Okay, the bottom number is your root. So that's what root we're going to take, or that stands. Notice the main difference between these is you can take the root first, then raise it to a power m, or the second one on the right, you can take it to the power of m, and then take the nth root. If we, well, it says evaluate with your calculator. You may use a calculator to check your answers. Let's just go ahead and use what we know. Hopefully you know 625, we have the 4th root. Hopefully you know you can break this down to the 4th root of 25 and 25. So if we look at that, we know that 5 times 5 times 5 times 5. So the answer is 5. 16, if we rewrite, just using the notes straight above, remember the bottom number is the root, so it's the square root. 2 you necessarily don't have to have. We're going to take the square root of 16, okay, and then we have parentheses. Let's put parentheses around the whole thing. So, for instance, the square root of 16 is 4, and then we're going to go 4 cubed, which is 64. 25, negative 1/2. Remember, the negative is reciprocal, so we're going to write this as 1 over 25, and then keep the 1/2. Okay, if you remember from the very top, 1/2 is really the square root. So we're going to take 1 over the square root of 25, which is 1/5. Negative. Start with the negative. Negative means reciprocal. So let's take the reciprocal, which is 9/4. And we still have it raised to the 3/2. Okay. Now remember, the top number 3, if we look above, is your exponent. The bottom number is the root. So we take both of these, distribute both, so it's 9 to the 3/2 over 4 to the 3/2. Okay? A little easier to write this is, let's take the square root of 9 and then cube it all over the, I've got to write this down there. It's going to be the square root of 4 and then cube that. Okay? Let's write it down here. So the square root of 9 is 3. 3 times 3 times 3 is 27. The square root of 4 is 2. So 2 cubed is 8. So our answer is 27/8. Alright, so we need to simplify the expression using all the properties that we know. So for number 5, remember we have negative 5 to the 1/3 times negative 5 to the 1/3 times negative 5 to the 1/3. Remember we have the same bases. So if we have the same base, which is negative 5, what are we going to do with the exponents? We're going to add. So we're going to add 1/3 plus 1/3 plus 1/3, which is negative 5 to the 3/3, which is just negative 5 to the 1st, or negative 5. Now we're going to take 6. We have 7 to the 1/2 times 28 to the 1/2. Our bases aren't the same. 7 and 28 are different, so we really can't combine, meaning we cannot add 1/2 and 1/2. So let's just kind of rewrite if we can. This is the square root of 7 times the square root of 7 times 4, if you want to say. Well, both are, the index is 2, so put them together. 7 times 4, which is, bring a 7 out, bring a 2 out. The answer is 14. Okay. Number 7, let's do the same thing, because 12, 45, and 50, really nothing in common yet. So we're taking, if you notice, the top number again is the exponent, the bottom number is a cube. We're taking the cube of 12 times the cube of 45 times the cube of 50, all raised to each of the first power. Okay. Well, all of them are cubed, so let's just put them all underneath. This is 4 times 3, 9 times 5, and 5 times 10. Okay. Now if we know, remember we need triads or triplets of each. So we have 3 2's. We can take a 2 out. We have 3 3's. We can take a 3 out. We have 3 5's. We can take a 5 out. Nothing left inside, so your answer is 2 times 3 times 5, which is 30. Writing each expression in radical form. Alright, so we need to take the expression that we have and write it in radical form. So use the exponential form, take it in radical form. If you remember, 4 on top is the exponent, 3 on bottom is the radical. So put the base first. Radical, it is a cube root. Put everything in parentheses, put the 4 on the outside. If you want, you can actually put x, raise it to the 4th, and then put the cube here. So either one of those works. The negative tells you 1 over t. Well, t is the 7th root, and then this is squared. Get rid of the decimal. Let's make it a fraction. So this is really a to the negative 16 over 10. Negative tells you to take reciprocal, and let's reduce the 16/10. So this will be 1 over a to the 8/5. That's all. 8/5 is a little bit easier to look at. Okay, which one's the root? Yes, the 5. So we're going to write 1 over a, the 5th root of, let's do it this way, a to the 8th inside. Okay. Or technically, we can say it's 1 over a 5th root of 5, parentheses, raised to the 8. Next 3, we're going to take the radical form and rewrite as exponential. So the opposite of what we just did on 8, 9, and 10. Okay, start with the base. The base is x. Okay, what's the exponent? Because that's usually the top or the numerator of the fraction. Exponent's 3. So this is 3, and the index is 2. So x to the 3 halves. M. What's the exponent? It's 1 and 3. So m to the 1/3. Okay. Be careful with the last one. You have both 2y squared. So use my parentheses. Okay. Both of those are technically raised to the first, but it's a third root. So we get 2y squared raised to the 1/3. All right, we're going to, for the next 3 problems, simplify this expression. So putting everything together for the last couple days, hit pause. Come back, see me in a second. Go. Alrighty, hopefully you can follow work starting here on the right over here, going down, just following through, coming here, and then finishing. So you should have 3x squared times the cube root of y squared all over 4y squared. For the second one in the middle, we're going to start, and what I did is, here's the simplified x version, here's the simplified y, so we really have x to the negative 1 times y to the 3 halves, and then all of that squared. So I didn't distribute the 2 first. Drop that down, distribute the 2 now, so 2 times 3 halves, and then 2 times 1. So the answer was y cubed x squared. And the last one is 2x to the 4th over 5y to the 5th. If there's any problems, be sure to check with me the next day. And always, do your best, forget the rest. Bye for now.
Hello? Okay, just a second. It's for you.